Hello Math 10 students. In this video we're going to take a look at compound interest in section 3.8. We're not going to focus on simple interest, although we will see a couple examples of simple interest just as a comparison to compound interest. If you need help with simple interest, please make sure to check out the video on that topic specifically. In our first example, we will have a simple interest problem. In this situation, we have Madeline, who's invested $2,000 in a savings account with a 5% interest rate for 1 year. We want to know what our account's going to be worth at the end of the year. I know this is a simple interest problem because it doesn't have the word compound or compounded in it anywhere. Compound interest problems will always have those words. So when I do these problems, I'm always going to do my first step, which is to identify my principal, rate, and time. We're going to label the P, R, and the T here. That's super important to make sure that you have all the right values that you need. So to start with, your principal is always your dollar amount that you were originally investing or borrowing if it's a loan. In this case, that's $2,000. Your rate's always a percentage, so 5%. And time should always be a number of years. In this case, 1 year. If you're given time in months, you'll have to do a conversion. And that's actually in step 2. Convert the percent to a decimal and months to years if necessary. Well, I do have to convert that 5% to a decimal by moving the decimal point twice to the left or dividing by 100 if you prefer to do it that way. Either way, you should get 0.05. Time is already in years, so I don't have to convert it to years. If I had been given months, I would have to divide by 12 to get years. And then last, I'm going to use the simple interest equation. The simple interest equation is I equals P times R times T. I'm just going to replace all those letters with the values that we have for them. So underneath the P, I can put the $2,000 that we have as a principal. Underneath the R, I can put the 0.05. And underneath the T, I can put the 1 for 1 year. So this becomes I equals 2,000 times 0.05 times 1. When I do that computation and work everything out, I get my interest is 100. Now, if I go to type that into Hawks, I'll get the red bar of shame. Why? What did I do wrong? Well, I didn't read the problem carefully. This question is asking us what her account will be worth at the end of the year. Now, if Madeline invested $2,000 and her account's only worth $100 at the end of the year, she's pretty upset about that. What do we need to do here? This $100 is just her interest. It's the I. That's the extra that she got. To find what they're asking for, we need to add that interest back to the principal. She'll have $2,100 at the end of the year. That's known as the final amount or final value, sometimes the total value or maturity value. After 2 years, what's going to happen? Well, you can pause and try this on your own if you'd like. If you worked it out, it should be an answer that makes sense. We're going to have the same principal and rate in the formula, but the time will be changed to 2. So I equals 2,000 times 0.05 times 2. I neglected to write those principal, rate, and times out to the side, but I would hope that you would do that when you're doing these at home. So when I multiply everything out, I get $200, and that kind of makes sense. $100 after 1 year, after 2 years, that'll go up to $200. She's getting an extra $100 every year, and it kind of makes sense. So you can see that the final amount here would be $2,200. What would happen after 3 years? Well, you can see the writing on the wall here. She's getting an extra $100 every year, so after 3 years, she'll have $300 on top of the $2,000, would make $2,300 her final amount. And if she's getting $100 every year, you can figure out what's going to happen for just about any number of years. After 10 years, she'll get an extra, well, 10 times $100 would be $1,000 extra dollars of interest added to the $2,000 will give her a total of $3,000 in her account at the end of 10 years. So Madeline's pretty happy and excited about that. It all makes sense, right? She's getting $100 every year. But does it really make sense? After 10 years, she doesn't have $2,000 in that account anymore. She has $3,000. So why is she still only getting $100 every year? Shouldn't she be getting more interest? Well, if her interest were compounded, she would. Compound interest is what happens when every year you take whatever interest you've had, sometimes more frequently than every year, but you take whatever interest you've accumulated and you add it back to your principal. That means that the next time you get interest, you'll get more than you normally would have. In general, compound interest is interest that's earned not just on the principal, but also on any interest that's already accumulated. we've got a formula for it. Now I'll stop you right now and I'll mention that the way that I'm going to do compound interest in this video differs slightly from the way that the Math 10 textbook does it. I'm actually going to follow the Math 101 textbook for a couple reasons. One, I think the Math 101 textbook, their method is a little bit cleaner. Two, if you're taking this class, you're probably taking it so that you can go into Math 101 next. And it's best to have some consistency here, since one of the first topics in Math 101 is actually compound interest. So let's take a look at how this formula works. It's a little bit different. Instead of the interest, I actually have the final value or total value for free. So I don't have to add the interest back to the principal. It's already done for me. That's done by actually this number 1 in the formula. That's the number 1, not a letter. That's actually the number 1. And what's happening, if you kind of think about these parentheses and distribution, the p kind of gets distributed into the parentheses, and p times 1 is p. So the principal gets added back in. Don't worry too much about that, but do understand that your formula here is going to give you the final amount and not the interest. Also understand that this number 1 is always going to be part of the computation. It's actually the number 1. And the last and most interesting difference here is that t is no longer being multiplied by the other numbers. It's an exponent. Now this whole compound interest formula is the first formula that we've seen that has exponents, and we'll be dealing with exponents a lot throughout the rest of the class. For right now, it's important to realize that your calculator probably has a exponent button on it. And if it doesn't, you'll want to make sure that you use one that does. So you can either use the calculator that comes with Windows, most likely your calculator on your cell phone. If you turn it into landscape mode, will have an exponent button on there, and we'll talk about how to use that button. But let's see if we can go through this process here of finding the compound interest. So here's an example of a compound interest question, very similar to the simple interest question, but the biggest difference is that now I've got that word compounded. So Madeline's investing the same $2,000 in a savings account with that same 5% interest rate. That hasn't changed, but now it's compounded annually, and it's for 10 years. What would her account be worth at the end of the year? Well, we're going to go through a similar process. We're going to label our principal, rate, and time. Principal still 2,000, rate is still 5%, time is 10 years, like the very final example on the previous slide. We're going to convert our percent to decimal and months to years if necessary, just like before. Since I'm given 10 years, I don't have to convert that. If I were given months, I would have to divide by 12 here. 5% will still change to 0.05. Now, there is a second bit of converting that I'm going to need to do if I'm given a compounded anything other than annually. If it says compounded semi-annually, quarterly, monthly, or daily, there's another conversion that I'm going to have to do. We're going to take a look at how that works in another video. For right now, this video will work for anything that says compounded annually. Now I'm going to have to use the compound interest equation instead of the simple interest equation. So how does that work? This equation is the amount, or the final value, is equal to the principal times, in parentheses, 1 plus the rate. And this little gadget here, this little pointy caret thing, is a symbol that's universally understood to be exponent, so the exponent of t. Two ways that you can write an exponent. You can write it as a sort of higher up number. Notice how the t up here is higher up than all the other letters, and it's a little bit smaller too. Or you can use this little caret symbol that should be with the 6 button on your keyboard above the letters. Not on the numeric keypad to the right, but the numbers above the letter, the number 6, you should see a little caret above it. So if you hold down the Shift key and type 6, it will put one of those little carets in. That actually also works in Hawkes Learning Systems. If you hold down Shift and type 6, that will make it into an exponent. It also works for if you're dealing with Microsoft Office products and you're using the equation editor in there, that will also make an exponent. So when I'm putting things into this equation, I need to remember that this is an exponent and not multiplication. But I'm going to go ahead and put my values in. So first of all, the principal becomes 2,000. The parentheses and the 1 stay as they are, plus my rate becomes 0.05. I close my parentheses, this little gadget to mean exponent, and then the t becomes a 10. when we evaluate this, we have to be very careful because you sometimes can just type this in as is in a calculator, but not all calculators deal with order of operations properly. So I'm going to actually evaluate this using order of operations. If you'd forgotten, that's the PEMDAS, the Please Excuse My Dear Aunt Sally. And the very first letter in there is P for parentheses. So the very first thing I'm going to evaluate are the parentheses. I'm going to do this addition inside the parentheses. Well, this is actually a very easy addition to do. $1 plus 5 cents, well, that's $1.05. So when I evaluate that, 1 plus 0.05 is 1.05. You can use a calculator for it, but after you've done a few of these, you'll notice that it always comes out pretty easily like that. You just have the decimal point preceded by a 1 in your answer. It'll be 1 point whatever came after the decimal. So I've done that, and I just bring down to the 2000 and the exponent of 10. All right, so next up, after P, parentheses are done. I know I still have them there, but I only have them to remind myself that the 2000 is being multiplied by the parentheses, so there's really a little multiplication dot there secretly. But the next operation is exponent. So I'm actually going to do this exponent right here. So if you don't know what the exponent button on your calculator looks like, it probably looks like one of the following three things. It might look like an X with a little Y above it. It might look like a Y with a little X above it, or it might be that little pointy thing, that little caret. It's probably one of those three things, though I have seen some other alternatives. Your exponent will not have a number in it. If it's X with a 2 above it, that's not the exponent button that you're looking for. It will never have the letter E in it. If you have an E with a little X at the top, that's something completely different. That's the exponential function e to the x, which is another very important button, but not something that we're going to get into in this class. So if you're not sure what your exponent button is and are having a difficult time, please feel free to send me an email or a Dropbox and ask about it, and we can try to figure it out together. Alright, so when I do that, I type my 1.05, my exponent button, and my 10, and I hit equals, I will get this horrible, horrible, long, ugly decimal. So try it out at home and see if you get the same thing. Type 1.05, then type your exponent button, whichever one it is, and then type 10 and hit equals. And make sure you get this dreadful decimal, 1.62889462677774441, and it just keeps going for a while. This is awful, but this is something that we don't want to round just yet because we still need to multiply it by 2000. Don't hit clear though, leave it in your calculator. Doesn't matter what order you multiply stuff in, so if you leave it in there and hit times 2000, that will take care of our last part of the order of operations, the multiply. And we'll get 3,257.789 and then a whole bunch of other stuff. But we can round this final number to the nearest cent, which is the 8 right here, the second digit after the decimal. So our final amount is $3,257.79. So what happened with compound interest, every year Madeline was getting whatever interest she earned added back to her principal, and instead of getting just $3,000, she got $3,257.79. So she made an extra $200 for doing nothing. It was the same rate, the same principal, and the same time. It's just the fact that her interest was compounded that got her extra money. To summarize, compound interest allows you to get more money if you have an investment, or possibly owe more money if you have a loan, by taking the interest that you've already earned and adding it back to your principal. You use a different formula to compute it. It's this formula right here that has an exponent in it. When you're putting things into the formula, if it says annually compounded or compounded annually, you can use this formula as is. For compounded semi-annually, quarterly, monthly, or daily, you have to do a couple adjustments which we'll go over in another video. Lastly, make sure that you know what the exponent button on your calculator looks like. You can evaluate this in your calculator by just typing things in as is, 2000 times 1.05 exponent button 10, if your calculator understands order of operations properly. Not all calculators do though, so it's good to learn how to do the order of operations in the correct order yourself.